Hey guys, I'm back. It's me on Strange Science Stuff channel. Um, this is one design I was trying. These are, ooh, these are strong. This is opposing magnets. I was just showing you how it's connected here. It's not easy fidgeting with magnets. They tend to stick. Okay, so this is free to move, and I put it at an angle similar to a Faraday setup. So if this was a Faraday motor, this would be the magnet, and this would be normally negative and positive, and then it would spin around. And I wanted to see if it would do the same thing with two magnets. They can't, they're opposed. But it almost worked. And believe it or not, when I held it with my fingers, it did go around. So this design actually could work if this pivot right here were over here and this is like falling on the magnet. So I could get this to work actually. It's not a bad design, but what I was planning was to spring load this to get more out of it. Ooh. But I actually have a better design I'm gonna skip to instead of this one. But I just thought I'd show what, I'm trying different configurations to see what's best before I make my final version. So I thought it was worth investigating because I've never seen one of these. So if you're curious what it will do, you can see it's a lot of force. It's actually bending and pushing. It actually bends the wood and it distorts pretty much all of it. It's a lot of force right there. So it would have been interesting if it kicked it sideways, and I kind of thought, why wouldn't it? Because it's kind of the same thing that happens when you put a Faraday motor when you turn it on. But basically, it matters where this, like in a Faraday motor, is hanging. So if this was hanging, and it also needs to be at a specific angle. I believe it's 42.5. But I have a better design that I'm going to jump to. So I do believe this is possible, and it would probably go about that fast when you got it going. But I'm going to skip to an easier design because it's a lot to fidget with. You probably have to specific machine it, and who knows if it would crush the metal. It's actually a lot of force, and that might throw off the slate precision. The only thing that stops this actually is that it's able to lean. It's actually pulling on this. It's like leaning instead of putting the force into rotation. It's like leaning, but it's almost going. Like that's actually less effort than it would take to spin the bearing. So it is doing something. And you see it's like trying to lift off. Keeps trying to lean. It's a lot of force actually. So it's not a bad idea, but I'm gonna skip to something that's a little less precision because I don't feel like machining. Okay, thanks. I'll be back. Let me know what you think. For my next project, I'm gonna be putting these in a bunch of like different geometries and seeing what they do. One interesting thing though is that amount of distance, if you calculate the electricity it would take to maintain that gap under pressure, that's actually, I was making an electric motor and I'm going to, but what's interesting is that is actually like hundreds of times more energy than a typical electric motor. There's actually more energy in magnets than electromagnets, which I didn't realize. I honestly thought it was the reverse, but when I put this together and I'm looking at the gap it maintains, like this is actually under pressure. This is, the gap is maintaining just from the force of the magnets. That equates to a lot of electricity. Like, talking, it would take hundreds of batteries to create that kind of force from here to here. Like, if you hook up an electromagnet and get it to push that far under pressure like that, there's actually a lot of power in there, believe it or not. So, I'm gonna try some different geometries to see if I can get the magnets doing more of the work and the electricity doing less. Okay, I'll be back. Thanks. Talk to you soon.